So we have been simplifying expressions for a while now, so that we could add them, so that we could subtract them, multiply them, divide them. But today we're actually going to be solving rational equations. Um, this means that we're going to have an equal sign. X equals some number. And whatever you do to one side, you got to do to the other. Remember, when solving an equation. And we should get some numerical answer. So some letter equals some number. Like everything else in this unit, let's revisit a simpler idea first. So we're going to practice solving this equation, and we're going to solve it in two different ways. So the first way to solve this, if we're trying to get x by itself, we would want to move the 1/4. So we would do that by subtracting 1/4 from both sides. You could get a common denominator, or you could type it in your calculator. If you do that, remember to put parentheses around your fractions. So for example, you would have 5/6 in parentheses minus 1/4 inside of parentheses. When we get this, you press math, enter, there's our fraction. So we end up with 7/12. So now I have 2/3 x is equal to 7/12. All right, now I need to get x by itself, so I would divide by the number in front. So I divide by 2/3. So that goes away. Again, you need to put it in parentheses. So you would have 7/12, your fraction, divided by 2/3. And remember, when you divide by a fraction, you really keep change flip, so flipping it and multiplying. So we end up with 0.875, math, enter. That would be the fraction 7/8. So here we ended up with x equals 7/8. Okay, so that might be the first way you think to solve it. But there is a way that we could just get rid of all the fractions, which we would probably prefer to do, so that way everything can be added or subtracted nice and neatly, no fractions necessary. In order to do that, we have to come up with some common number for a denominator, right? We got to multiply these all by something that will make these fractions go away. So we're trying to think of the smallest number that all three of these will go into. 3, 4, and 6. All of these are multiples of 12. So I am going to multiply all of these fractions by 12. Okay, so when you're doing this, you divide the number here, and then whatever you get, multiply it by the top. So 12 divided by 3 is 4. 4 times 2 is 8. So we have 8x for this first term. Right here, so I'm going to do 12 divided by 4, which is 3. 3 times 1 is 3. We have an equal sign. Now we're going to divide by this bottom number. 12 divided by 6 is 2. And 2 times 5 is 10. And now we solve. So much easier numbers. We would subtract 3. 10 minus 3 is 7. So I have that 8x equals 7. Divide by 8. And we still ended up with x is equal to 7/8. So hopefully you would agree with me that the second way we did this was a lot easier when we got rid of the fractions. If not, it's going to get really complicated when you have fractions with not just numbers in the bottom, but variables, and you can't type it in your calculator. So our plan is to always try and get rid of the fractions by doing what we did here, trying to figure out the least common denominator or multiple in the bottom there. Okay, so in this one, remember we always factor first to see if it has anything in common with the others. So I would factor the bottom here. And then I would have y and y. I need something that multiplies to give me 12, adds to give me -1. That would be a +3. and a negative 4, which it turns out is what these already had. So what I could do here is multiply the whole thing times y plus 3 times y plus 4, because that would be our common denominator, or least common multiple. So before we try and do that one and actually multiply each term, let's try it with some simpler ones first. So here we've got x, 4, and 2. So I'm looking for the smallest thing I could use for that. Well, the number I can use would be 4, but I would also need it to have an x. So I'm going to multiply everything times 4x. All right, so if I was to do that, we use that same rule. We divide by the bottom, so 4x divided by x, that's going to make the x's go away. So I'll just have 4, and then you multiply 4 times the top, 6. 4 times 6 is 24. All right, plus 4x divided by 4. The 4's would cancel out, so I just have x, and then x times the top, x times 3 would be 3x. Equals, so we divide by the bottom, 4x divided by 2 would be 2x. 2x times 3 would be 6x. I mean, sorry, would be 6x. And then I would need to move all my like terms to the same side. So I would move over the 3 by subtracting it. And then I would have 24 is equal to 3x. And then I divide by 3. Oops. I divide by 3. And I would get that x equals 8. Okay. All right, so on these don't even have fractions, so I could put them over 1. That would mean that I have 1, 1, and m. So the common denominator, or least common multiple here, is just m. M divided by 1 is m, and m times 5 would be 5m. M divided by 1 is m. M times m is m squared, and we had a minus in between there, equals m divided by m, so the m's divide out, equals 6. All right, so we have something with the m squared, an m, and a constant. So this is going to be something we're going to be able to factor. We just need to move everything to one side of the equal sign to do that. So I want to move these things over here. So to move the m squared, I would have to add it. I got m squared. And then to move the 5m, I'd have to subtract it. So minus 5m. And there's already a 6 over here, a positive 6. And this equals 0. All right, so now I could factor this. So I'd have m and m. What multiplies to give me 6 and adds to give me negative 5? That would be negative 2 and negative 3. And remember, if you want to see what those really are, you take what's in your parenthesis and set it equal to 0, and I would end up with m equals 2 and m equals 3. All right. Last one on this page, we're looking for a common denominator between x plus 3, 2, and 10. Well, the 2 and 10 are just numbers, so I could turn the 2 into a 10. But this x plus 3, I can't break it up. So I can use the 10 for a common between these, but I'm going to have to just have an x plus 3 because it's its own thing. So there's my least common multiple or common denominator. All right, so we divide this by the bottom. If I divide 10 times x plus 3 by x plus 3, my x plus 3's are going to cancel out, and I'll just have 10, and then multiply it times the top. 10 times 2 is 20. All right, plus here, we're also doing 10 times x plus 3 divided by 2. Well, I could divide the 10 by 2 and get 5. So I would have 5 times x plus 3 times 3 on the top. So if I wanted to, well, here, let me keep, I'm going to run out of room anyway. Okay, so we can simplify that part. So we only have a 20 plus, I can multiply the 5 into the parentheses here. So that would end up being 15x plus 3. Still, sorry, try that again. 5x plus 15 when I distribute. And this is still times 3. So then I would distribute the 3. And so then I have 20 plus 15x plus 45 equals. All right, so that one was a little messy to simplify. Okay, now the last one, 10 times x plus 3 divided by 10. Well, on that one, the 10s would cancel out. So I would just have x plus 3 times 19. X plus 3 times 19. So I'm going to have to distribute that 19 into the parentheses. So we've got 20 plus 15x plus 45 equals 19 times x would be 19x, and 19 times 3 will give you 57. All right, so now I would combine like terms over here. 20 plus 45 is 65, plus 15x equals 19x plus 57. All right, so I would subtract 15x from both sides, and I end up with 4x. Then I would subtract 57 from both sides. 65 minus 57 gives me 8. And then my last step would be to divide by 4, and I end up with x equals 2. All right, flip it over in the back. So if you remember in the last lesson, we said, you're going to wonder why I'm asking this now, but you'll see later. And I asked you if x plus 2 and x minus 2 were the same thing. We plugged in 2. We said no. Then I said, what about 3x minus 4 and 3x plus 2? Again, we said no. In fact, we said, even though these are two terms, it actually just represents one number. That is important for later. Well, here we are in the later. So it's important here for you to realize that x plus 1 and x minus 1 are not the same thing. So I can't just move or add or subtract a number on the ends here, right? They're their own separate pieces. So again, if we're going to want to solve this, remember we factor what we have to see if there's already anything in common. So this is a difference of squares. So it'd be x plus 1 and x minus 1. So it turns out that is something that these two already have. So that means that my least common multiple, or my common denominator here, is just x plus 1 times x minus 1, because this one already had the plus 1, this one already had the minus 1, and this one had both. Okay, so it may help to write what you are doing over each one for now. So remember, we're multiplying this times x plus 1, x minus 1, just on this very first fraction here. Well, when we divide by the bottom, those cross out. So then I just have to multiply the 2 in. So 2 times x would be 2x, and 2 times negative 1 is negative 2. Right now I'm doing the next section here. So I do x plus 1 times x minus 1. When I divide, the x minus 1's cancel out. And then I just am multiplying negative 1 times these. So negative 1 times x is going to give us negative x, and negative 1 times 1 is negative 1. And this is equal to, then on this last one we have x plus 1 and x minus 1. And look, all of it cancels out, so all we're left with is negative 2. And then we solve for x. So the first thing we would do is combine like terms. So 2x minus x is x. And then negative 2 minus 1 is negative 3 equals negative 2. Add 3 to both sides, and we end up with x equals 1. All right, let's do another one like that. So we're going to factor the bottom. So I have y and y. I need something that multiplies to give me negative 12, adds to give me negative 1. That'd be negative 4 and positive 3, which is something these already have. So that must be my least common multiple or common denominator. So y minus 4 times y plus 3. And remember, I'm going to do that to each piece. So y minus 4 times y plus 3. On the first fraction, the y's plus 3's cancel out. And then I multiply the 2 into the parentheses. So 2 times y would give me 2y. 2 times negative 4, negative 8. All right. Now I do it for my next fraction. Y minus 4 times y plus 3. The y minus 4's cancel out, and I multiply the 4 into the parentheses. So 4 times y will give me 4y. Positive 4 times positive 3, positive 12. All right, and then my last fraction, I cross out, and I'm left with the top, which was 2y minus 2. So over here, I'm going to combine like terms first. 2y and y would give me 6y. Negative 8 and 12 would give me positive 4 equals 2y minus 2. Then I subtract 2y from both sides. I get 4y over here. And then I subtract 4, and I get negative 6. Divide by 4, and we end up with y equals negative 3/2. Okay. All right, here we need a common multiple, least common multiple. So we've got x, x plus 2, and 1. Well, luckily 1 doesn't really change anything, but that does mean that these are totally different, right? Not something you can just add a 2 to over here. That's not how it works. So our thing that we're multiplying everything by is going to be x times x plus 2. And you can do the 1 as well, but remember 1 doesn't really change anything. So I'm going to be doing each piece times this. So first one, x times x plus 2. Well, the x's cancel out. 4 times x is 4x. 4 times 2 is 8. All right. The next set, we've got x times x plus 2. The x plus 2's cancel out. So I'll have 3x times x, which is 3x squared, and negative 2 times x, which is negative 2x, equals, over here there's nothing that's going to cancel out in the bottom, so I have to multiply the 3 times the x, which would give us 3x times x plus 2. Then I have to distribute the 3x in. While I'm at it, I'm going to go ahead and combine any like terms over here. I just have a 3x squared. Then I have a 4x and a negative 2x, which give me positive 2x plus 8, is equal to 3x times x would be 3x squared, and 3x times 2 would be positive 6x. So I need to move the x squareds to the same side. So I do that, and those go away. Then I would move this 2x over here with this x. So all I'm left with is 8. equals 6x minus 2x gives me 4x. We divide by 4, and we end up with x equals 2. All right, last one. So this one is something we can factor, so we need to do that, see if there's anything in common going on. So difference of squares would be x plus 1 and x minus 1. So luckily this one already has the minus 1, so that would mean that our least common multiple or common factor is x plus 1 times x minus 1. So in the first fraction, that's all going to cancel out, right? All these with all these, all we're left with is the 3. Plus, here we would do the x plus 1 times x minus 1. And if I multiply that by 1, it just stays the same. So x plus 1 times x minus 1. And then on this last one, x plus 1 and x minus 1, well, the x minus 1s will cancel out. Then I multiply the 2 in. 2 times x is 2x, and 2 times 1 is 2, so plus 2. All right, so I've got 3 plus, then we have to FOIL this out. So we would have x times x, which is x squared, x times negative 1, negative x, 1 times x is positive x, 1 times negative 1 is negative 1, equals 2x plus 2. All right, over here, these two things cancel out, and I can combine the 3 and the negative 1. So I'll have x squared plus 2 equals 2x plus 2. All right, so I need to move everything to one side so I can factor. So I subtract 2x from both sides. So I have an x squared, a negative 2x. I need to move this 2 over here as well. And those go away. So equals 0. Now I have x squared minus 2x equals 0. So I can pull an x out of both of those. So I have an x times x minus 2 equals 0. And remember, we take everything and we set it equal to 0. So I would have x equals 0. And I would have x minus 2 equals 0. If I add that 2 to the other side, I end up with x equals 0 and x equals positive 2. So look for that least common multiple, multiply each piece by it, cancel out what you can so you can get rid of those fractions.